Hey everybody again. So we are still in week 9 and we are doing mini lecture 17 today where we're going to be focusing mainly on Pangaean climate. So before we get into actual Pangaean climate and what the climate was progressively becoming more like during the Permian and the Triassic, which is what we talk about today, let's take a little bit of time to talk about deserts. So deserts form in many different ways, actually. So you may be familiar with subtropical deserts. There are also continental deserts. There are rain shadow deserts, coastal deserts, and polar deserts. So you may not think of the North and South Poles as deserts because they're cold. But the thing that all deserts really have in common is that they are dry. So here is a map showing the distribution of the deserts around the world today. Deserts are shown either by the very, very white features in the North and South Pole, or the light tan colors that you can see along the equator in portions of the Middle East and Asia, and also in portions of the Western United States, Australia, and South America. So you can see that they're distributed throughout the world. So what do they all have in common? Well, I've already mentioned this, aridity. So aridity means that they are all dry. They have very low precipitation and moisture. And this has to do with the amount of moisture that's actually available due to atmospheric circulation. So for example, here's how subtropical deserts really form. So sunlight reaches the equator very directly. It heats up the equator, and as it heats the equator, warm, moist air rises. Warm air rises. So that moisture is picked up and it gets into our atmosphere, and then it's circulated to the north and to the south in what are known as Hadley cells. As they're circulated, they lose their moisture as precipitation, which really makes the tropics very tropical, right? So that's how we get our thriving plants and biodiversity there. But as it moves further north and south, that air loses its moisture, it cools, and that cold, dry air descends in a low pressure system. That descending air is what causes our deserts at around 30 degrees north and south latitude to form. There's just absolutely no moisture left for them to have. And so that's just one way that our deserts form. But there are many other ways that this forms, and this also works for continental deserts. So when continents are very, very vast or very large, for instance, Europe and Asia connected together today, we get continental deserts that form because the moisture falls out as it goes across the continent and it never reaches certain areas. So, for instance, the Gobi Desert today is a continental desert because the moisture falls out before it can reach that area. Now, Pangaea would have been very, very similar to this with the vast size of the continents. So how do we know that it was getting very, very dry at the time? Well, we use paleoclimatic evidence. One type of paleoclimatic evidence is the types of rocks and minerals in those rocks themselves. So, for instance, red beds, or the color red, is produced by being exposed to oxygen, which means that these sediments had to have been exposed to the air, which at least indicates a land environment. Now we also have here gypsum layers, and we've talked about gypsum previously before and how this is a precipitated sedimentary rock. So that means that it precipitates out from solution as water is evaporating away. So what that also tells us is it must have been dry enough that evaporation was very, very high. There are other ways to study paleoclimate, and this is actually one of my favorite subjects. So paleoclimate is the study of past climates. And as you saw, we can use the rocks themselves, but there are many other indirect ways we can observe past climates as well. We can look at the fossils, both micro and macro fossils. So for instance, there is evidence of plants and land life at the time in the Triassic. You can also look at mini fossils to see what kind of temperature waters were. Was there a lake there? Were there rivers? Was the water cold? Was the water salty? And those are some things like forams, diatoms. But you can also look at fossil pollen, which can tell you what type of plants were in the area. And plants have certain conditions that they like, right? And then finally, we can also use the geochemistry, which is related to the actual elemental composition of materials. So to summarize, there are many ways that we can study past climate. If you're curious about Triassic paleoclimate, I'm happy to give you some reading materials on that. Pangea is obviously something that many people are familiar with, but not a lot of people might think about how the continents coming together like that really impacted the climate and how the climate impacted the lifestyle of animals at that time. Again, I hope you enjoy the rest of this lesson, and thank you for listening to this very, very short mini lecture.